We've got here a question that's asking us a practical application, if you will, of domains and ranges. And we have a rectangular piece of cardboard that's 18 by 24. So here's my rectangular piece of cardboard. Look at how straight those lines are, of 18 by 24. And in the corners, there are squares cut out that are x by x. So I'm just going to draw them in by hand, and it's certainly not going to be as beautiful as the rectangle. But never mind, this isn't an art class. Okay, so this distance from here all the way across is 24 centimeters, which means that if I cut out a square at that end and a square at that end, each to the length of x, then what I'm looking for is this distance, which I'll mark in blue, will be 24 minus 2x. So, now in the same way, when I look at, if you will, the height, this is 18 centimeters. So when I take the x and the x out of there, I end up with a height of 18 minus 2x. And finally, when I fold these corners up along, let's say, my green dotted lines to make a box, my height of that box is going to be x, and my lengths are going to be 24 by 2x and 18 minus 2x. So if I'm going to make a function with volume v of x, that's going to be my length, which is 24 minus 2x, times my width, which is 18 minus 2x, times my height, which will be x. Now, let's try and clean that up. I can take a factor of 2 out of this, so I'm going to do that. So 2 of 12 minus 2x. Sorry, that should be 12 minus 1x if I take the factor of 2 out. Then I can also take a factor of 2 out of that one. So I'm going to write times 2, 9 minus x, and then times x. So that comes out to be 4x, 12 minus x, and 9 minus x. Now, that's my function. Now, the next thing I need to look at is the domain. And I know that my volume in the real world must be greater than or equal to 0. I can't have a volume that's negative. So therefore, this function must be greater than or equal to 0, which means that each of my brackets must be greater than or equal to 0, because x needs to be a positive distance. So I know that much already, so I'll keep that in mind, that x must be greater than or equal to 0. Otherwise, we're not folding anything up and it just doesn't make sense. But I also know, therefore, that this bracket, which is the critical one, if x is larger than 9, then this becomes negative. And once this becomes negative, it means ultimately that my distance x is so much so that it meets itself here, and I'm folding it across this middle line. I'm folding it across the equator, if you will. So therefore, I know that x must be less than or equal to 9. So if I'm going to talk about my domain, I can say, so therefore, my volume function x is 4x, 12 minus x, 9 minus x, where x is between 0 and 9. And I'm going to use square brackets because if you want to, you could argue square or round, but what I'm going to say is that it's possible that we don't fold anything up at all, therefore the distance would be 0, and it's possible that we fold this sheet in half, in which case the distance x would be 9. But that is my complete answer for my volume function and my limited domain.
If you found this video helpful, please subscribe or like. Thanks.